The last part of Module 5 is going to be actually solving quadratic equations. So first thing you need to make sure you understand is we are actually having an equation. We're going to have it equal to 0. The direction is going to say solve. The other problems are going to say factor. So that's really important that you differentiate between these two types of problems. When you're factoring, you're wanting to get it down into parentheses, into different binomials or trinomials factored out. When it says solve, your goal is to get x equals. So the first thing, again, we're going to use on every one of these problems is what's called the zero factor property. And y'all already actually should know this. If I tell you that if I multiply two numbers together that I get 0, then it means one of them has to be 0. So the property says that if you have it factored, though that's really important, and you have a product, which is the factor, then one of the factors has to equal 0. So I like to break this into steps. So the first step is it has to be in standard form. Standard form means ax squared plus bx plus c equals 0. So you have to have it equal to 0. Next step, we're going to factor it completely. So if it's already factored and it's equal to 0, we're now going to skip to step 3, but that's important. It has to be equal to 0 and in factored form before you can split it up. Then we're using the zero product property, which says that one of the factors has to be 0, and we'll solve those equations. So we're going to look at number 12. Number 12 is equal to 0, and it's already factored, so we're skipping to step 3. We take each separate factor, set it equal to 0, and we solve. The mistake I see people make on tests is they just think, all right, I'm just going to say it's equal to -7, and that's my answer. In this case, once you subtract 7 from both sides, which gives you 3x equals -7, you then also have to divide by 3. So one of the answers is a -7/3. For my right-hand factor, I'm going to add 5 to both sides, and then I'm going to divide both sides by 2. So my solution for this problem, and I should expect two answers, are a -7/3 or 5/2. It doesn't matter which one you write first. Both are an answer. If you have a quadratic, you expect two answers. Linear, which is what we've been dealing with before this, we expect one answer. If it's a cube, we expect 3 answers. You can always check your answer by plugging it back into the original problem. So going to number 13, it's equal to 0, which is step 1. Now we need to factor it. This is one I want you to be able to do with trial and error because the leading coefficient's a 1. There's no GCF. So it has to be an x and an x. Because this is a minus, we have a positive and a negative. The only choice for 5 is 5 times 1. So when we have 5 times 1, we have to just be careful on which one is the positive. It's a positive 5 and a -1 because we want a positive 4x when we add them together. If you get the sign wrong, the whole problem is going to be wrong because now we're done with the step 3. We will now take each separate factor, set it equal to 0 and solve. On the left-hand factor, we will subtract 5 from both sides. That gives me x equals -5. The right-hand factor, I'm going to add 1 to both sides. So my answer is -5 and 1. Doesn't matter which one you put first. Again, the mistake people make, though, is they just think they automatically change the sign. The reason why we're changing the sign of my factors is because I'm actually solving for x. So I'm adding and subtracting to move from one side to the other. Going to number 14. First thing that's wrong is it's not equal to 0. So we need to add 15 to both sides to get it equal to 0. Now it's in the correct form. There's no GCF. We're going to factor it. Leading coefficient's a 1. So again, this is one I want you to do in your head. The signs should be both negative because if this last sign is positive, they have to match the middle. Choices for 15 would be 1 times 15. That's not going to give me 8. The other obvious choice should be 3 and 5, and when I add those together, that will give me the -8. So now I take each different factor, set it equal to 0 and solve. So we'll add 3 to solve for x on the left-hand factor. I will add 5 to solve the right-hand factor. So my answer here is 3 and 5. Again, to check this, you would want to plug it back into the original problem before you've done anything. I would suggest on the test at least checking one of them, because if one works, it generally means you factored correctly. But if you make a sign mistake, it can cost you the whole problem. So going to number 15, please pause it anytime you need to. First thing you should notice, sorry about that. First thing you should notice on 15 is that it is a binomial. Binomial means I'm going to factor by difference of squares. It's the only option we have in this class. It has to be equal to 0 first. So we're going to check. That would be 3x quantity squared. That would be 4 quantity squared. So we'd factor the difference of squares says take one of the first plus one of the second, one of the first minus one of the second. So I have 3x plus 4 and 3x minus 4. We now have it factored. We separate them, set them equal to 0. On my left-hand factor, I'm going to subtract 4 from both sides to move it to the other side of the equation. And then we are going to divide both sides of my equation by 3. On my right-hand factor, I'm going to add 4 to both sides to move it to the other side of the equation, and then divide both sides of my equations by 4/3. So my answer is a negative 4/3 and a positive 4/3. Again, I can check that by plugging it back into the original problem. Going to number 16. Problem with number 16. It's not equal to 0. So subtract 49 from both sides. Then we're going to factor by, again, looking at what's my rules. This is 2 terms, which means does it fit a difference of squares? You're going to see a lot of difference of squares in Module 6. This is x quantity squared and 7 quantity squared. So it'll be x plus 7, x minus 7. So this gives me x plus 7 equals 0. Subtract 7 from both sides to get x equals negative 7. X minus 7 equals 0. We would add 7 to both sides. So my answer for number 16 should be negative 7 and 7. If it's a difference of squares, you should get the same number, but the opposite sign. So the last one for this section, it's equal to 0. We can do this problem with trial and error or the AC method. I'm going to go ahead and use trial and error because I can see that 5 is prime. My signs will be opposite. Again, I don't know right now which one's positive and which one's negative, but it would be 5x and x. That's the only way I can get 5x squared. Same idea for 5. I can't put the 5 in the first parentheses because that would create a GCF. So it's got to be a 1 and a 5. It's really my only choice other than changing my signs. So I have to FOIL this out to make sure it works first because I got to check my signs. Gives me 5x squared minus 25x plus 1x minus 5. That gives me the negative 24x. Please make sure your sign is correct. If my sign had been a positive here, then I would have to flip my signs. So I'm going to just rewrite it. I have 5x plus 1 times x minus 5. Set each one of them equal to 0. So in the first term, I'm going to subtract 1 from both sides and then divide by 5. For the x minus 5 as a factor, I'm going to add 5 to both sides. So my answer here is negative 1/5 and 5. Easy to check. You have to have your signs down. Please check your work.